and how to equip them such that they hit the ground running as they join the industry. Gladly, we've been enabled for this webinar and supported by one man that have done that for a bulk of his life, and he will be sharing his experience. And this hands-on experience, we hope, will provide enabling impetus, foundational impetus to our lecturers who have joined to see how to do this best. I think I'll have to stop at this point and hand over to the moderator. My name is Elias Arochukwu. I am the chair of the Data Science and Engineering Analytics Technical Session African region. It is my pleasure, therefore, to invite my co-chair, Mr. Engineer Chi Ibe, who will be moderating this webinar. Chi, over to you, please.
Yes, thank you very much, and confirm you can hear me, Elias.
Loud and clear.
Okay, amazing. So again, Elias has said it all, and again, once again, welcome to this webinar. We have two fantastic speakers today who will be taking us through, a lot of what Elias has laid out before us, how the data science and engineering analytics can make that connection between the industry and the academia. Without much ado, I would like to, display the agenda for today. So Mike, if you want to maybe project, and so we can go from there. Mike, can you hear me?
Okay, all right. Yeah, I'll do that now.
Okay, thank you. Okay, thank you very much. So we all got the invite, and so yes, we've gone through the first item on the agenda, which is really the opening remarks by the chair of the DCIT Africa region, in the person of Elias, one of our, great supporters on this in this effort. The next will be introduction of speakers. And then we'll go through the presentations by the two speakers that we have today. And thereafter, we'll go through a question and answer session. So if you have any burning questions, please keep them to the end of the session. You can use the chat feature to capture those thoughts and questions or comments. And thereafter, we'll have how SPE can continue to support, the seats in this effort of, continuing to grow our fluency in data science, not only within the industry, but also making the connections with the academia. And then we'll have messages from our sponsors and then closing remarks. So that's what we have lined up for today. I'm excited and hope you are to listen to the lectures and then have a very engaging session. Hopefully we can take something away from this meeting, from this webinar. So without much ado, I would go ahead to introduce our first speaker of the day. He's an amazing gentleman and digital guru by name Michael Aku. He's also one of us on the DCIT. Michael is a digitalization and corporate innovation manager at Cyber Crescent, where he leads integration and development of artificial intelligence applications to tackle challenges in the energy industry with a dual technical expertise in petroleum engineering and software development. Michael provides technical direction to development team, creating cutting-edge technological solutions and strategic implementation roadmaps, which ensures adequate delivery of the solutions. He recently won the Society of Petroleum Engineers Africa Region Award on Data Science and Engineering Analytics, owing to his drive and initiatives in supporting development of technology solutions in the industry. Michael drives artificial intelligence application development, where he leads a team of AI experts and machine learning engineers to build simple and affordable AI platforms for process optimization and resource utilization. He has worked on several AI projects, including predictive maintenance for critical components, chatbot for quick document retrieval, equipment health monitoring application, digital well book, digital fluid distribution chart, well integration, and so much more, management solutions, and integration of petroleum, integrated petroleum economics applications. Michael is a mentor with the Tony Elumelu Foundation, where he mentors startups and entrepreneurs on digital transformation and corporate innovation initiatives in running their businesses. He's also currently serving as a member for Founders Institute Worldwide, where he acts in the same capacity as an astute mentor, providing strategic roadmap and helping entrepreneurs grow their business across Africa and Europe, while adopting digital transformation techniques. Currently, Michael is focused on leveraging artificial intelligence, big data, cloud computing technologies to create novel solutions that address challenges and concerns in the energy industry. He is a member of the steering committee of the Data Science and Analytics, Engineering and Analytics Technical Section of the Africa region, where he champions corporate innovation, technology development, and data-driven solutions for teaming members of the SPE in Africa. He is happily married to Mrs. Afyong Ako, who herself is a software engineer, and they are blessed with a son. Don't ask me what the son would be, but I'm excited for that young man. Ladies and gentlemen, please join me to make welcome Michael Ako. Michael, you have the floor. Thank you.
All right, thank you very much, Chi. Thanks for that introduction. Rightly said, like you said, I don't know what he wants to also be, but his choices are much in his front. All right, welcome everybody. My name is Michael. This session, just as Elias has given the introduction, what we intend to do is we'll try to see how we can help African universities collaborate effectively with the industry. We are looking at what are the challenges the industry has. How can African universities tap into it? Because the idea of running the university as a higher educational institute is to ensure that when people leave the university, they are well equipped, they are solving problems for the industry and the society. And that's where when you talk about economic empowerment in terms of employability, entrepreneurship, they are well grounded. As she has rightly said, I'll be speaking on that. And then this is the outline for our session. I'll start off with an icebreaker, and then I'll run through key concepts. Some of the concepts might be familiar with them. And then I'm going to talk about pretty much about the industry and talk about the academia a bit, and then share some insights in terms of the need for collaboration. And Professor Jim Crumpton from Colorado Schools of Mine is going to take us through what he's currently doing in terms of from the academia perspective and how he's motivating his students to solve industry problems. And then we're going to share opportunities and collaborations endeavor across the board. So I'm going to start off with this icebreaker, right? When I join my organizations, and pretty much in all organizations, there's always, safety is very paramount. And one of the most interesting things about safety is there has to be a safety sign. So you have a lot of safety signs, keep left, you have sharp objects here, don't touch this. And of course, safety is always the same thing, right? And most times when you are approaching areas where there are drainage or there are probably a lot of things to be done in those areas in terms of maybe they are trying to make it clean a bit, or there are some works going on, you always have the wet floor caution. And one of the interesting things about having the wet floor caution is that for some reasons, I still see people have these trips and they still sleep, despite the fact that it's a wet floor. There's a wet floor caution, right? But people still have their sleeps and trips, you know. And it piques my interest because the sign that you're seeing, it means it does not necessarily push you to be preventive. I think people become more reactive when they see a sign, right? And that is one interesting scenario that I've actually played through all my life. Like, whenever there's a sign, it seems the sign is supposed to be preventive, but in this case, the sign is actually, people still tend to be reactive. I have a couple of friends who have actually had slips and trips, and it's not actually funny, but then it's always interesting that the sign says safety first, but then are we still safe despite being notified to be safe in the first instance? That's the first icebreaker I have. The second icebreaker is okay, the picture you're seeing there is is copyrighted. It's my son anyway, you know, and pretty much one of the challenges about being a first-time dad is that you learn a lot of things, right? When my son arrived, I was not aware of the kind of world that I'm going to find myself in. One of the most interesting things that happened was this, you know, a young baby, and then the next thing is crying. And when he's crying, I notice my mom and, you know, mother-in-law and my wife, everybody's trying to find out why is he crying. So they say, oh, bop him, you know. And some women on the call understand. No, no, those. I say, check the pampers. And some people will say, no, he wants to, no, maybe he's hungry. Or maybe there's something. And there's one that always catch my interest. Like they say, he wants to sleep. So I'm like, if he wants to sleep, why don't he close his eyes and sleep? Why must he cry and everybody has to run up and down? So the thing is that when toddlers or babies or, you know, infants, when they cry because they can't speak, you have to iterate, find out what's wrong, you know. And you're going around circles like, try this or try that and all that. And then one day I was just thinking and I said, is it not possible to have an AI system, an AI platform, or, you know, a digital tool that will just listen to the cry of the baby and tell you the exact problem, you know, rather than running up and down and say, oh, try this or try that and all that. These are typical icebreakers that pique my interest in terms of artificial intelligence, in terms of providing solution, in terms of research, because of course, you know, research is looking for solutions to existing problems. The problem around people still falling down when there are safety signs, that's the problem. And then issues around having to, you know, the infants cry, basically. And so pretty much over time, what we've done as, you know, as both from an industry perspective, right, and from an academic perspective is that we're very good at reporting results. So you see, you have a lot of data and probably you have some information. They say, come and show us what your result is. So you have reports, 10-page reports, 50-page reports, you know, some of those reports are very nice, but then we just report them. And after reporting them, what happens? Sometimes those reports are just kept somewhere, right? You know, maybe some other time when someone needs to look at something, picks up those reports. Or for some, they could probably, you know, look at the report and say, oh, we think there's a chart there that is a bit useful, right? But the question is, should we keep reporting results or should we begin to influence outcomes? What if we have research that is solving a particular problem? Take, for example, HSE trips and fall. Before you get to a wet floor caution, you probably have a system that flags in front of you that there's a danger ahead. And because it's shining at your eyes, you're not moving forward, you have to move back. That is, the outcome of you not falling or falling has been influenced. What if we have solutions that typically will help you predict how the industry wants to reduce costs, you know, and then you could provide those solutions in terms of probably they're looking at cost reduction or they want to optimize processes, right? So these are things that we're looking at. Can we move? The artificial intelligence leap is saying, can we move from just reporting results, keeping those research endeavors, keeping them there, And can we move to creating solutions out of them and influencing outcomes? And that's what AI is all about. And so pretty much a lot of people still find it difficult to understand what artificial intelligence is. Some people mix the concept, right? When they hear of artificial intelligence, they begin to say, oh, this is AI. And some people, when it's not even AI, they still attribute it to AI. So I'm just going to give a brief. Any system that is able to interact with human and is able to mimic human interaction and provide results is artificial intelligence. That is what it is. Simply look at it from the fact that when I flashed my slides on, right, you are able to see something and then you're able to get an information to your brain. Those artificial intelligence systems over time have also been trained to recognize things. And that is what an artificial intelligence system is the bigger picture, integration of systems, sometimes integration of machines, sometimes integrations of mobile devices, and then behind the scene runs algorithm, which we're going to see as we go on. So AI system is actually systems that interact with human and are able to provide insight, and then you could have this kind of interaction and patterns, in terms of recognizing patterns and problem solving, basically. What are the use cases of machine learning or AI? And I'm going to explain the part of machine learning or whether AI. Yeah. First of all, clinical diagnosis. Pretty much a lot of people use AI in terms of health. Before I joined the industry, that was, I think 5 years ago, about 8-10 years ago, I was working on a research where we're trying to predict lung cancer using artificial intelligence. So we had images of the lung. We have good images of the lung. We also had images that had patients with lung cancer, and we're training those large data sets whereby when you bring in any image of the lung, it will detect that this is lung cancer. The reason we're doing that is this. Most times, what we found out was that the doctors seeing images can make them make some subjective decision, right? They could pass some subjective opinion because over time, they've probably seen a lot. So we try to use an AI system to help. So I'm just trying to say that that's something that's done. And over time now, there have been a lot of improvement in terms of AI for clinical diagnosis. Predictive maintenance. Yeah, I mean, the industry is using systems that predict failures, condition-based monitoring. You have an asset, the asset is about to fail. You are notified on time that this asset is going to fail, you get the notification, and that's what actually happened. Of course, identification. Most of us have probably smartphones that we unlock with our faces. I mean, those are things that are AI-driven, basically. There's ride sharing and mobility service. And of course, there's a particular one that came out last week, which I was supposed to update on this slide. It's called, they call it AI for media reporting. Even though there are some, a bit of kind of, a bit of ethics around that. But I mean, you have TV reporters now, they don't have to go to the field, right? You could generate AI images that could mimic human and give out those TV news reports. And that's how the world is moving right now. So these are some of the use cases of AI. That being said, if you remember the first icebreaker I mentioned about safety, take a look at this. Let me go back here. This is an AI system that is HSE compliant. It's trying to identify when the engineer is not without an hard hat. Typically, when you're on the facility, you're expected to wear an hard hat, right? So the red signal there shows that he's in potential danger because the hard hat is supposed to be on. But if you look at the next picture, you could see the one with the hard hat has the green signal showing he is potentially safe. So you could use AI system to, ensure HSE compliance because there could be cases of human errors and human forgetfulness where people who are supposed to be HSE compliant, having their hard hats on, they may forget, and then it can lead to, a lot of issues. That's why when it comes to consequent HSE consequences, you're talking about loss of properties, you're talking about loss of lives, you're talking about damage to equipment, and you're also talking about low morale of the individual. That's the first one. Remember the second icebreaker about my son, crying and then everybody running up and down trying to get what's wrong with this guy. I mean, let's find out what's wrong with him. Currently, there's an app called the Ubenwa app. It actually takes infant cry and it could tell you exactly what's wrong with the child. A lot of people, it's being used across countries. It's actually developed by one of our colleagues who actually is now running his own startup called Ubenwa in Canada. And then also, you know, a lot of digitization went into that, got a lot of baby cry sound and analyze that to do that. So I'm just trying to explain that artificial intelligence is so much more in our lives now, and it's beginning to redefine and reshape how we think and how we do things. And it's also creating that awareness that we all need to latch into it. That being said, I mentioned earlier that when you hear AI, some people still confuse AI with machine learning, with deep learning. So I just want to create kind of a clarity, right? Machine learning is just typically a subset of AI. What machine learning does is that when we come to data, there are workflows for data. You have data acquisition. That's where you're able to get the data. The data acquisition will be gotten from the data source. When you have your data acquisition, the next layer is data interpretation, right? And you're able to interpret the data. And then the third layer is the data visualization. Your machine learning helps your data interpretation, prediction, pattern recognition. But at this level, it deals with algorithm at a much more safer level. What that means is that it doesn't require much compute resources. It doesn't take a longer time to do that. You could use some very few frameworks. You just say, I'm using machine learning to analyze this data. That's a very simple way to, you know, talk about machine learning. I'm using machine learning to carry out prediction, right? In everything you're doing, you know, there's weather forecast now. You could use machine learning to do weather forecast prediction. You could use machine learning to, you know, inflation of goods and services over a period of time to predict whether there will be inflation or not, giving out relevant information. You could use machine learning to analyze data set. You could even use machine learning to analyze your spending habits and your spending pattern, right? I'm proud to this time. Someone reached out to me and said, hey, I need an app that will help me in terms of my expenses. So it could show you spikes. It could show you peak areas where your money is actually going into, and it could also recommend some save mechanism. You know, a lot of people, machine learning is there for the oil and gas industry, for predictive maintenance. I think currently I work with some, you know, students actually in the master's program in Institute of Petroleum Studies, where we're using machine learning to predict sand production. And what they were looking at was immediate, when it begins to produce the sand, the immediate sand, not the total sand production, but at that inception, right? So a lot of places. Now, when you come to deep learning, just from the word deep, it means now you're looking at much more broader integrated algorithm, right? You're looking at a kind of subset of machine learning that is actually trying to use large compute resources, large and vast amount of data, right? You know, and is able trying to learn, you know, patterns in that large amount and vast of data. We'll see that sort, and then that's where your deep learning comes into play. There are some key concepts that are very common. You have supervised learning, you also have unsupervised learning, and you have reinforcement. Now, these are key concepts. Some of these things, Professor Jim will come and explain to you how they are being used, but I'll just explain the supervised learning. In the supervised learning, just a very basic explanation. Just see it as a mother having a child and then trying to cross the road with the child, right? So he sees a traffic sign and then he tells the child, the red says stops, the green says go, the yellow says ready to go. So there have been classifications according to colors, right? Red means stop, green means go, yellow means ready to go. So in terms of supervised learning, you're actually doing more of classification, your image classification, your speech recognition, Alexa and all the likes, your text recognition, autonomous vehicle, you know, those are elements of supervised learning. That's because the vehicles have been trained to identify objects, the human objects, the traffic signal, buses, you know, they have the shapes of the buses irrespective of what they are, lanes that you move through, houses and all that, stop signs, road signs and traffic signs. And that's autonomous vehicle. That's classification because these objects have been classified. In terms of unsupervised learning, basically you're not classifying the data. So you just get a wholesome data and then you dump it, right? And then it begins to learn. It tries to identify features in that data. So I'm going to use a very typical example, right? So, you know, there's what you call Black Friday. I mean, everybody wants to go out. Black Friday is cheaper. The reason it's cheaper is because Black Friday, ideally, you know, the prices are supposed to be way cheaper and then large people come in to buy, right? So if you take that data of the sales of Black Friday, you will know that you're going to see a pattern of people who come to buy cheap things at that particular period of time. And then because it uses certain statistics from your K-means algorithm to identify those certain features. So it's able to use certain features for a particular data set, right? Maybe a particular set of people probably like going on holidays, maybe during summer or whatever. So he's able to pick those features and then he classifies those people. But the thing is that there's no human interface doing the classification. It just takes the data and it runs with it. The third one is reinforcement learning. So typically, reinforcement learning can be explained using a child, right? So in terms of reinforcement learning, the AI system is being trained using the reward and consequence management system. So what that means is that when it's able to identify a particular data, there's a reward for it. If it's not, there's no reward for it. Just see it as asking a child to probably come first in an examination, and you probably provide a bicycle for the child. That's the reward system, right? And then if the child cannot come first, there's no reward for the child. So that's reinforcement learning. So at that point, the AI system knows that there's a reward if I'm able to get this pattern right. So he's able to ensure that he understands every attribute of that data. And in so doing, he wants to ensure that he gets the pattern right, because if he does it, he doesn't get a reward. So he goes back and then he's coming back to, repeat the same process again. And that's what it's all about. Another concept you probably have heard, a lot of people hear this a lot: natural language processing, ethics of AI, computer vision, bias, and fairness. So typically what this means is in terms of natural language processing, some of us are familiar with, chatbots such as ChatGPT, Bard AI, and the likes, right? These are NLP-driven applications. What that means is that using certain semantics and tokenization. So, for example, the system is able to recognize. Let's say, for example, I say, I'm going to the office. I want to run a report on weather, or I want to run a report on asset management in my office. What happens when you key in that into your chatbot system is this: it uses what we call tokenization, using transformer models. What happens is that it looks for keywords like office, reports, assets, and then it's able to map it with certain similar keywords, around again, applying certain token to them, such that when it sees similar keywords, it's able to predict what the next sequence of text should be. So if you're using ChatGPT, one of the best ways to use ChatGPT is to be very good with your prompt, because it is how you craft your prompt, it will respond to you. If you give it a very generic prompt, it gives a generic response, but be able to, recraft the prompt and tailor-made it towards your intention, you're going to get output. I'm sure some of us have also heard ethics of AI, ethics, and that's where ethics are, you are talking about, remember when I mentioned that last week, I just saw a news media coming up and saying that they have a channels, a TV media called channels.ai, right? I mean, it looks very nice in the sense that typically think about the wars happening around, and a TV reporter has to go to the war zone and report live from those places. Their life is at stake. There could be loss of life. There could be a hostage situation, a lot of that, right? But if you use an AI system to do those reporting, you're not probably going to have those loss of lives. But then on the other side too, you now begin to ask, I mean, even in the era of social media, we had a lot of fake news, right? A lot of fake media reports. So how do we mitigate this fake, fake news, as the cases may be? And that's one of it, and that's why people are saying, what are the ethics governing AI? Take, for example, a second example, autonomous vehicle. I think precisely 3 years ago, a particular autonomous vehicle was driving, and of course, there's nobody driving it. And it came across a particular vehicle and almost had a head-on collision, and it swerved to its right. In doing so, it hit a woman. And when it came for time for legal issues, the question is, who are we going to sue? That's because people who design autonomous vehicle make it known clear that the autonomousity of the vehicle and the obligations of the vehicle, they are distant from it. So the question is, who are we going to hold responsible? Is it the AI system, or is it the people who develop the AI system, right? So these are questions that people are saying we need to have great governance and ethics regarding AI. We need to ensure that people don't create, and don't spark conflicts using AI, right? And these are things people are looking at, especially with respect to artificial intelligence. What are we sure that somebody somewhere will not use artificial intelligence to cause a rift or conflict between two nations? Who is going to take care of the responsibility of the AI? Who is going to ensure the fairness and the biasness, typically. And of course, there are cases where this particular third incident about ethics of AI happened when somebody reported in one of a company that anytime they search for murderers or search for cases of violence, it mostly brings up Black people's image. And then she said that she was not too convenient and she was saying it's only Black people that carry out violence and all that. So the question now arises because AI system is the data that's been trained with it. So who is actually taking cognizance of the data that is being used to train the AI system? What if there's a data imbalance? What if there's a data bias in the training of the AI system? Those are what ethics of AI is trying to, and then privacy and data protection, right? And then computer vision, medical image diagnosis, object detection, and the likes. And also, like I mentioned, bias and fairness. These are some terms with respect to artificial intelligence. There could be a danger of a single data point. This means because we have a single data point describing something, how are we sure that that data is exhaustive enough about that information? That being said, so these are just some key concepts. So if you want to address an AI system from both an industry perspective and an academia perspective, there are 4 components here. The data is very important, like I mentioned earlier. The process that you're looking at is very important. The people, very, very key. And the organization, either the academia or the industry. For data, as mentioned, cannot be overemphasized. It's very important. You need to be sure that it's the right data that you're using for anything you do. Take, for instance, the infant cry, right? When I say infant, maybe I mean children from 0 years to probably 1 year or 2 years. Infant, if you bring in a toddler, probably 4 years, 5 years, a toddler cry into the system, you've actually polluted that data because that's not what we're looking at. So data needs to be cautiously sourced. Data needs to be cautiously QC'd. That's quality checked, right? For errors, for some disturbances, for noises, as the case may be. And that's the essence of the data. You have to ensure that it's the right data that is going into the system to give the right output. How about processes? A lot of people still struggle with process, and basically process is one thing. Think about it that one of the very simple joke I crack around is even having to sign papers. You still have people saying, take for instance, you want to sign a hard copy document, right? And then they say you have to print, you have to sign, you have to upload again. There are e-signatures. So whatever process in place, if the process is not accommodating your artificial intelligence system, that system is going to fail. So you need to look at what process do we have in place. Think about a place where probably everybody has been told to use Microsoft Teams to collaborate. And then all of a sudden, anytime there's a meeting, people have to drive down from their homes to the office to meet physically. You wonder what's the essence of the Microsoft Team. So you need to have processes that are in place because processes can actually help and drive things. And then people needs to be made aware, just like what we're doing this webinar. We need to also, talk to people about these systems. There needs to be an enlightenment on the trends of AI. There needs to be a discussion on the benefits, on the possibilities of research that academia is doing and how it affects industry. The industry also needs to come out and say, these are our seemingly challenges, right? And what role can you play as an academia to that? And of course, the organizations, institution, basically needs to also adopt policies that will ensure that people can have, look at probably things around AI systems and say, what can we do with this? And of course, that also applies to the industry. But that being said, I mentioned earlier that data is very important, and which is also something we see. The essence of this webinar, like I mentioned earlier, is for us to see how the industry can collaborate with the academia in terms of research. What you have on the screen is currently the major focus of the industry. The major focus of the industry has always been around these 5 elements: increase production, save cost, improve efficiency, improve safety, and carbon footprint reduction. And these are like a major pain point which is stretched across every industry. If you pick any industry and you superimpose their objectives into these 5 items on the screen, you're going to see that what you have there is something they are ideating on or something they are thinking of working with, basically. So this means this is their objective. This is like what their bottom line. We want to increase production. It could be in the manufacturing, it could be in the oil and gas, it could be in consumables. Every industry wants to actually increase production. At the same time, they want to reduce costs. They want to be profitable to sustain the industry in the long run and to also have funds to, reinject back to the organization, right? They want to reduce costs as much as possible. They want to be efficient. How can we be as efficient as possible? And they want to also improve safety because a safe life, safe environment ensures people work effectively. And of course, the whole wave around climate, carbon reduction footprint, they want to ensure that they are in line with the SDG 7 or SDG 9 goals in terms of carbon footprint reduction, climate, the whole sustainability goals that we're looking at. And these are actually the focus of the industry. The points assigned to each of them varies in any industry, but basically, if you take it down to the oil and gas industry, this is what they are focusing on. If this is the major focus of the industry, what lever can help them achieve this? Emerging technologies can, right? From IoT, artificial intelligence, cloud computing, blockchain, robotics, automation, a lot of things, 3D modeling. These are levers that can actually help the industry achieve what they intend to do, either in terms of increasing production, reducing costs, improving safety, carbon footprint reduction. COP28, a lot of commitment to see how much we could reduce gas flare, how much we could reduce, carbon emission to the atmosphere. People are looking at energy management incentives where if I come to an office and I'm not too busy in the office, all the lights in the office don't have to be on at the same time. Some lights could trip off. I could save energy, and saving energy means I'm saving costs, right? Some industry are already integrating a hybrid, energy generation, energy system where they use solar to manage certain part of their businesses, and then they use the normal, probably electricity to also manage their business. So you look at all that, and then you think about how people are talking about carbon footprint reduction. Every essence of what is being discussed, the lever that can actually help is actually technology. But the truth is this: technology is an offshoot of research, which means that research will drive the development of technological solutions. And research in whichever form, either from the academia or from the industry, is a major pointer. Now, look at this. We're coming to the academia now. I saw this some few weeks while I'm trying to prepare for this. African universities have a very big research influence, right? This is, if you look at the chart on the left, you have publication outputs, the numbers in thousands, a lot of publications, journal publications, a lot of, publications are out there. People write theses from master's program to PhD program to postgraduate diploma program to undergraduate program to even postdoctoral research programs. A lot of research is out there in terms of African universities, and there's so much we churn out every day. And we have a lot of scorecards to even say, hey, this university this year actually produced about 1,000 research, 2,000 research. And quite interesting. But the question is, if we have such volume of research, are they really solving problem that is beneficial to society, which is the industry, which is the major focus, right? If we have that volume of research that has been done, are they targeted towards solving industry problem? And that's where the question comes in, where people say, hey, we've done so much research in our department this year, and then this year we have an outflux of graduates from our department again, masters, PhD, undergraduates, churning out. These are their research thesis. You look at our shelves, we also have existing research there. And then they probably meet the HOD and say, oh, there's no more space. And then he says, hey, we need to get another office where we can actually stockpile thesis again, right? We domicile them there, For some reasons, they're supposed to be solving the industry problem. They're supposed to be like a handshake, right? But that's not happening. We're just keeping this research there. We're not allowing it to flow into the society. Remember that I said that the industry problems are around HSE, cost reduction, process improvement, profitability, carbon footprint reduction, right? But industry have their problem. But we also say we're doing research. So it seems that there's a bit of stockpiling of research, and there's a bit of, I think, a bit of a wave around saying we've done so much research, or we're keeping them there and we have to stockpile them. But the end goal of this conversation is supposed to be a synergy. The industry shares their problem. This is what we are looking at. These are the current research we are looking at. The academia pick up that problem and they're able to work on that research and churn out solutions and give back to the industry. And that is the essence of this, what we're discussing today. And when that is done, there's going to be, the synergy will bring innovation. Innovation, basically the academia, when they churn out those research will be technology solutions that the industry will get. There could be a win-win situation where the academia gets equity in those, solutions, or they could get some form of revenue, some form of, incentives, right? Basically. Then also in terms of talent development and workforce readiness, think about it that the students in the academia are currently solving their research project is tied towards solving industry problem. By the time they leave the academia to work for the industry would not need to retrain them to understand industry problem again. So they're actually ready for the industry, right? Basically. And of course, economic growth and competitiveness. That's a major pointer, right? Economic growth and competitiveness. So basically, if the academia is able to help, like if the industry shares the problem, academia come in and take those research across all layers of the academic institution, you could have all this happening. That will be all from my end. Professor Jim is going to come in to now explain what he's doing in his own school as academia and how he's also solving industry problem. Thanks. Over to you, Chi.
Thank you very much, Mike, for that excellent presentation. You took us through from your icebreakers to, talking about AI and the applications, the key concepts, the digitalization process, workflow, opportunities for collaboration between the academia and the industry. You also talked about some of the key challenges the industry is facing and how we can leverage AI. Really excellent delivery there. So without, let me introduce our second speaker of the day. Is no other than Professor Jim Crumpton. He's an accomplished veteran in the oil and gas industry, graduated from the Colorado School of Mines with a BS in Geophysical Engineering in 1974 and MS in Geophysics in 1976. Prior to joining Chevron in Denver, Colorado, he later earned an MBA degree in 1996 from Our Lady of Lake University, San Antonio, Texas. Mr. Crumpton worked on the IT merger integration organization study in 2001 as part of the Chevron Texaco measure, which developed the IT organization structure and its strategic direction for the corporation, where he received a President's Award for this activity in acknowledgement of his contributions in application of information technology to business problems and in working to develop industry standards in electronic data exchange. Jim was named as Chevron Fellow in 2002 and served as the chair of the Fellows Network from 2006 to 2008. He retired from Chevron in 2013 after 37 years of meritorious service with Chevron. And since moving from Houston to Colorado, he established Reflections Data Consulting company to continue his work in the area of data management and analytics for exploration and production industry. Jim was a distinguished lecturer for the SPE in 2010, 2011, speaking on the topic of putting the focus on data. He's a frequent speaker at SPE conferences on digital and intelligent energy and the Data Foundation. Why only a digital immigrant? Jim has embraced social media with the help of his daughter, Emily, a real digital native, and is a fervent blogger and has experimented with YouTube-like videos to help train and mentor the new generation of digital natives and digital engineers entering the oil and gas industry. In 2013, Jim co-authored a book titled The Future Belongs to the Digital Engineer with Dr. Dutch Holland, focusing on the issues of impact of emerging digital technology on oil and gas operations. Jim also worked with Dr. Steve Cooper, president of Energy IQ, on the new book, The Digital Journey of the Oil and Gas Industry. In 2017, Jim was named as the PNEC Cornerstone Award winner for the career accomplishments in data management. Jim serves as the PDM Denver leadership team to help organize activities for the local group. In October 2019, Jim received SPE's International Award recipient for management and information discipline. Jim is currently Professor of Practice, Petroleum Engineering, Department of Colorado School of Mines, a position he has been in since March of 2020. Jim teaches on undergraduate level course in Petroleum Data Analytics in the Petroleum Engineering Department at the Colorado School of Mines. The course is the capstone course for the Data Analytics minor in Petroleum Engineering, along with Dr. Bill Utz. Jim has developed 2 graduate online courses in data analytics as part of an online graduate certificate program offered since the fall of 2020. He continues to teach and help develop a strong digital literacy in PE, in petroleum engineering students at Colorado School of Mines. Ladies and gentlemen, please join me welcoming Jim Crumpton to the webinar. Thank you. Jim, over to you.
Well, thank you. And I want to thank Elias and Chi and Joy for inviting me to be part of your webinar this evening. Actually, it's early morning my time because I'm sitting here in Colorado. But I appreciate the opportunity and the invitation. I've been around this industry quite a long time, so certainly I'm a veteran. It's up to your opinion whether or not what I've accomplished much, but I've certainly seen a lot of change in the industry, and I can go back when I got my degrees in geophysics. The petroleum engineer pretty much was satisfied with an Excel macro workbook, and he could do his decline curve analysis. They could do an awful lot of engineering analysis sort of techniques. And occasionally the reservoir wizards, they needed a big computer in order to do their computational fluid dynamics problems on their reservoir. But for the most part, the production engineer didn't have a whole lot of data to work with, few sensors here and there on the equipment. And they had, these engineering rules of thumb that they work with that work pretty good on conventional reservoirs. But the world changed, and the advances in computer science, data science, the analytical sort of techniques have not really come from the industry. So it's not a problem of invention for the petroleum engineer. It's a matter of adoption, because an awful lot of these things, as Mike talked about, I mean, they're in medicine, they're in finance, they're in climate, they're in supply chain, in economics, and all sorts of different ways. So now these tools exist. It's just a matter of recognizing how helpful they can be, identifying the business problem, maybe learning a little bit of a programming language like Python, and in order to try to kind of move forward. So if I could have the next slide. Okay, let's next slide. Here we go. I was on the School of Mines campus in Golden, Colorado, about 2018, and I was just attending a meeting of the student section, and there was a friend of mine who was the previous SP president who was giving a talk, and I was curious to see what what she was up to. But when I was there, I was approached by the department staff because they were looking for a someone to develop and teach a course that would be the capstone course, the senior class course to complete the data analytics minor, which we had launched the year before. And so they kind of cornered me and said, "Jim, could you do this?" And so I reluctantly, maybe foolishly, accepted, and I went on, and I've been teaching now for the last 5 years. So I'm going to give you a little bit of the experience that I have gone through developing an academic course when my background is largely industry, as she was kind of describing. And I think so some of the problems that and challenges, opportunities that I've had. First of all, was why does a petroleum engineer need to learn data analytics? The data science program at the Colorado School of Mines is co-sponsored by the computer science department and the Department of Advanced Mathematics and Statistics. And so, clearly, that's a place where a lot of these data scientists, get their advanced degrees, particularly the advanced mathematics and statistics department. But it really turns out, and I think with all of the digitization of not only our oil and gas industry, but many others, it now turns out that engineers have to become digital engineers. And the whole concept of digital literacy of the engineering workforce is more than just what you could do with Visual Basic on an Excel macro. That we really, I guess if you talk about it with whether it's an offshore platform, and I have had the great opportunity to visit one offshore Angola several years ago, or it was at Quito, from the Cabinda enclave that we visited. But from that to the shale unconventional reservoirs in the North America and to others, we have a whole lot of data. Matter of fact, we have so much data that I say we've broken Excel. But inside all of that data can sometimes be some very interesting insights that an engineer needs to have. So we've gone beyond automation. I mean, that was part of the early days of the digital oil field, where the automation of process control systems, electrical and control system engineers, with the computer science IT side of all of those things, as they converged, they created a data-rich environment that enabled the engineers to kind of not only get a better understanding of what was going on, but to create more accurate predictive models. And some of them were still physics-based models, like computational fluid dynamics. Some of them were just data-driven, kind of models like decline curve analysis, or the others. They become more and more complex, and clearly the whole world of machine learning, deep learning, now generative AI, are contributing massive new tools, and they're tools that are not just at the hands of the specialist data science people, but they are tools that, at least some of it, can trickle down and be used by petroleum engineers. And that was kind of the purpose of the course that I was asked to kind of teach. It was kind of convincing, and the next generation doesn't need that much convincing. Maybe some of the older generation needs some convincing, but some of the new generation knows that the world is digital, or at least there's a digital version of what is going on. And so clearly, this idea of seeing petroleum engineering as a simple mechanical operational kind of thing is outdated. And we can do a lot more with the tools that we have. Next slide, please. So the view of our profession, and here I'm saying petroleum engineering, even though if you go back into my academic background, I am a geoscientist. But the idea of an analog oil field, I mean, yes, it still exists. I mean, it didn't go away. We need a drill rig to drill a well in the ground. We need a well with all of the topside, the wellhead, the processing equipment to produce the oil and gas from the reservoir over its life cycle. So it isn't that this has gone away. This has been complemented by a digital environment. And so now, we actually can show you drilling rigs that are essentially run by robotics. I can take that driller's kind of room and it doesn't even have to be on the rig floor anymore. It could be hundreds of kilometers away in a remote decision support environment. That's largely how we do directional drilling anyway, as we've taken the directional driller off the drill rig floor, put him in a remote decision support environment, give him all this information, given him the access to the data from the measurement while drilling uh, data package, and allowed him or her to drill directional wells. So we've added to this analog oil field with a digital oil field. And that is the environment that the next generation workforce needs to be prepared for. If they come in educated by the previous kind of techniques, I mean, and I'm not saying throw physics away. This is a challenge of physics and statistics, not physics or statistics. You do not want to run an oil field without a concept of what are the physical processes that we are establishing. You have that. So, here's a question about from Jess about is the new workforce coming in that is probably overly optimistic? Well, in some ways, yes. I think, Jess, you got a good point that maybe the new workforce thinks everything's going to be digital and everything's going to be great data, everything's going to be all automation, everything's going to be um, related to just high-tech modern technology. We have an awful lot of the oil field that still looks like it did in 1970s. And that's kind of part of the challenge of the oil and gas industry right now, is that it has both kinds of worlds that live in it. The legacy fields, which are largely analog, and the modern fields of offshore um, uh, Tanzania, the offshore Namibia, the new fields in Angola and Nigeria. All of those are highly automated with awful lot of new data, systems that are available for the rest of this. So clearly, you can think everything is great when the answer is no, it's not. I mean, they still have an awful lot of the older systems that run and that work. I mean, the definition in the oil field of a legacy system is something that works, and so don't throw it away. Kind of an opportunity. But we also have, in many ways, many cases, increasingly that we have a digital version of it. Now, one of the things about technology obsolescence is, maybe the new next generation workforce comes in and looks at all this stuff like, like a smartphone that they change every year. And that's because the next version has so many cool new features. Well, we don't change our SCADA systems out every year just because the next generation has some cool new systems. We may not change the SCADA system out for 20 years or until we have maybe an enhanced oil field recovery technique, water flooding, or that we're trying to do in the field. So clearly, we are living with some older technology that has less data than the newer ones. That's certainly, some of the problem of integration of some of these tools that some places we have way more data than we need, and some places we don't have enough. Next slide, please. So that was the challenge that I was asked to kind of tackle at Colorado School of Mines in the Petroleum Engineering Department. So first of all, I created a capstone senior level class in petroleum data analytics. And clearly the first thing that you taught is analytics isn't new. I tend to, maybe not very modestly, claim that geophysicists were the first digital engineers or scientists in the oil field. But seismic data is a great example of an analytical technique that's been around for several decades, or more than that, actually. So we've been used to processing data. And I can remember back at 24 channel seismic recording. And now it's 80,000 channel seismic recording. So there's 3 or 4 orders of more of magnitude of data intensity than we have now than I did back when I started. But in geoscience, with seismic data, petrophysics, geostatistics, spatial data, in engineering with our empirical tables, equipments of state, numerical simulation like computational fluid dynamics, even in economics where we're putting data into our system, where essentially we're not just wanting to know, how it would work, but we're trying to figure out how much money we're going to make, profitability analysis as we go through things. So with regard to that, so data analytics is not new to the oil industry, but the new data science techniques and tools are pretty new. And so that is something that the petroleum engineer, mechanical engineer, chemical engineer, geoscientist all needs to figure out which ones of these new tools are really going to help us. Next slide. Well, one of the first major breakthroughs in the digital oil field happened about 20 years ago, 15, 20 years ago, when essentially, as I was talking about, all of the automation systems that were, essentially developed, mechanical, and civil, and electrical engineering sort of systems, the systems that ran the things in the oil field or any other factory kind of manufacturing sort of processes, all of a sudden we could take the data that were captured from those sensors and control systems, and through the kind of the democratization of the IT systems, be able to bring that into company corporate, sort of IT environment as you go through this. So with that, all of a sudden now the engineer sitting in the office had access to the data, the same data, maybe with just a little bit of latency. So it's not real, what people refer to real-time systems that aren't really real-time systems, but they're pretty close. And instead of getting data every hour or day, you can get it every minute if you want to. Um, and all of a sudden, this convergence of OT and IT, as it's called, really created the digital foundation for the digital oil field. Which, like as Jess has pointed out, not every oil field is a digital oil field, but many are, and many have been transformed to. And so it's that kind of environment that the digital petroleum engineer needs to be able to take advantage of. And I'll show you just in a minute some of the new expectations that are put on a young petroleum engineer. And it's not just you're responsible for 5 wells. Now you're responsible for several hundred wells in terms of production optimization. So that there is a lot more data and more parts of the system that you're responsible for. But it is also what is happening now versus what is going to happen, the future telling part of all of this. Next slide. So I was fortunate to have a department head who recognized that this was the new world. And this is Dr. Jennifer Miskimmons, she was very anxious to support this sort of program and development of this. So it actually went with, and my uh, teacher, Dr. Bill Eustace, who specializes in the drilling side of things. We put together this course uh, in the undergraduate data minor, and then we went further, and this was COVID time, so we had to do on virtual platforms. We developed 2 more courses as part of a graduate level petroleum petroleum data analytics certificate sort of program, which kind of recognized this new world that was coming on to us. And really, what this environment was not just more data, the digital intensity sides of things, the number and variety of new sensors, the field automation systems, the smart equipment that is being manufactured, where you don't just have a sensor on a pump, you have a whole Internet of Things device sitting on that pump, which allows you to optimize the performance of critical equipment. And it isn't just proactive maintenance that Mike talked about. That certainly was one of the first kind of applications that really was in wide use. But you can then begin to optimize the performance more than just when it breaks. It's when it's starting to get sick, or when you just have some 10%, 20% kind of tweaks that you can do on the pump and make it work, more effectively. But now we begin to have this interconnection where, again, field to office, field to the analog world to the digital world. The connection between, and this digital world here is often called these days the digital twin, which really came from the manufacturing side of our world, not, again, something not invented for oil and gas, but is very applicable and very useful to be used in that. We began to, instead of going away from highly proprietary systems where just one company's system carried everything, we started using public systems. And so with that brought us some standards, and that brought us some opportunity to grow, kind of further with regard to that, and connect our suppliers to this. So this entire new world essentially changed an awful lot of work processes. And that is kind of what we wanted to try to talk about. A number of students entered my class thinking I would make them better programmers. They were uh, they were definitely disappointed. Because what I tried to do was to say, what are the new work processes, the new challenges that you have? Still being a petroleum engineer, not if you wanted to learn how to improve your Python programming, I just recommended they went back to the computer science class. But it was what they use this stuff for that was really the emphasis of the additional training that we have. And just to kind of build on a point Mike made that I think is very important, the collaboration between industry and academia. Because I invited industry experts to come and do guest lectures in my class, particularly around drilling, and then the whole idea of how the data that we now have about the drilling rig, even though that's one of our biggest piece of mechanical equipment that you can take a picture of and impress your friends with, but it is all of the data that we're recording there, and how that changes how you drill a well. But also data donations. I mean, being able to work with a realistic form of data that only the industry has access to. If they could donate at least parts of that to a student to do their homework assignments or their projects or whatever, that is amazingly valuable for what kind of things they can have. And maybe, some of the software that they have of use, although, academia doesn't have a whole lot of money for software licenses. But the good news is there's a whole lot of open source, freeware sort of things that the academia can use that are still very useful technology tools. But also as mentors. I developed kind of a process I call the Shark Tank panel, where the students' course project for the semester, they essentially had to put it together as a team and then deliver it to the class. And of course, I was sitting in the back of the room doing the grading. But I invited this industry expert panel that would sit, and the student team would present to the industry panel, and they would give them feedback just like they did if this was a project when they become employees of the thing. So that kind of industry and academia collaboration is extremely valuable, and I think it made my class better than it would have that if it's just me lecturing about some of these concepts. I mean, I can remember a lot about what the industry wanted, but I've been away from the industry for 10 years. So I wanted current, fresh. This stuff changes so fast that 10 years away from the industry, and there's a lot of things that have changed. So I need the help of the industry to show exactly what's going on now. Next slide, please. So this whole idea of the digital twin. So again, it's the physical system and the mathematical digital system. It is the physical equipment and processes and a drilling rig and production facilities, as well as the computer model. And it is not that you just use the computer model to first design the system before you construct it. It continues through its entire life of the physical asset. And in that way, there's a kind of a technique called managed by exception. Essentially, you take the model's predicted simulated results, compare them with the actual results on the productive facility, and you begin to judge your actions based on the difference between those two. It isn't just set limits, the high pressure, low pressure limits that you have on a SCADA system. That's older generation kind of thinking. But if I now have a dynamic view that I have these things and I'm constantly updating the model because the model is never perfect, but that's not the point. The model is close enough to drive important decisions that you make. So now you have this idea of the two interacting on a near continuous basis. And with this, you can even do what if analysis on your digital model before you spend the money to drill another well. You could look at how to complete a well, how many wells you need in a water flood. What sort of pressures do you need within the field in order to do that? You can run those thought experiments on your digital model and then all of a sudden then figure out what's the right one and then apply that in your physical oil field. So saves a lot of money, reduces a lot of risk, particularly reduces a lot of capital expense when you want to try to talk about doing all this. So what we're doing here is really a very interesting opportunity of called multi-physics, multidisciplinary kind of an approach. So it isn't just a petroleum engineer worrying about the reservoir. It is a drilling engineer worrying about the well. It is a production engineer worried about the topside equipment. It is the facilities engineer worrying about the facility, particularly offshore. That is critical. But you're having them all get together, and the whole concept of the asset team within the industry now all of a sudden are working off one model. And we never used to do that. We used to have our own models and with our own assumptions and our own technologies. Now it's just one. Now it's this bigger picture of all of the disciplines within the oil field and also a life cycle view of the field. Excellent. Well, it's kind of the observation of where we are now. The digital oil field is a reality, although, as Jess pointed out, not every field is a digital oil field, and we certainly have some legacy technology from way back my generation time that we're there to try to deal with. The trend in field automation continues to grow, but now these things are getting smarter and smarter. When we're going to talk a little bit about generative AI, where all of a sudden these models begin to learn off of massive amounts of data sets. And that's one of the kind of big advances where we're now getting into this idea of learning. And that's the whole concept of artificial intelligence is can the computer begin to think like a human? To begin to not just perform actions that are pre-programmed into the system, but to learn from different new changes within oilfield behavior. We have the real-time drilling and production systems. We have earth and reservoir modeling that are in much greater precision than we ever had before. So going from the earth model to the reservoir model, it doesn't need such a massive amount of assumptions and upscaling that we try to do. And we do have this collaboration and visualization between field and office, this innovation at the edge. Most of the interesting new stuff 20 years ago happened in the office. Now it's happening in the field. But we're not all there. There's still significant integration gaps and fragile integration challenges between disciplines and places where we don't have the data we would like to have it that are still part of the challenges the next generation needs to address. Next slide. So my last set of comments will be about preparing students for the future. Because this next generation, in a sense, will be leaders in their digital literacy sort of comments. I mean, back when I joined the industry, back in the Cretaceous time, I tell my students, and if they don't understand their geology time periods, actually believe me. But essentially, the supervisor knew exactly what I was doing, and they were not only my business supervisor, they were a technical expert, and they knew the tools that I could do, so they could give me advice and help me with my ideas. Today, with this fast emergence of digital technologies, the student may be the better programmer, may be the better model builder than the more experienced supervisor has. So we get into this issue of is a supervisor any more the technical expert? And I think it's growing over the fact that the answer is no. So some of the programming code, some of the modeling techniques, some of the statistical analysis, it may be that the student of 1 or 2 years experience has got more skill sets around this than the supervisor or manager of 10 or 15 years experience. So the new generation is hitting the ground with digital literacy, but not a lot of experience about what the business problems are. The supervisor, the management staff know what the problems are, but they don't know the new tools. So there's a new interaction between the new next generation workforce and the current generation workforce. Next slide. So this maturity doesn't happen overnight. And it's kind of the concept of you can find legacy fields that are still in generation 1, or you can find new fields that are in generation 3 of this maturity sort of model that I talked about. And essentially, the industry is in all of these places all at once. And so what project you're assigned to, what technology tools that you have to available will depend. And that's, kind of one of the interesting kind of challenges. There isn't a one size fits all digital oil field. So engineers, young engineers, experienced engineers, we have to work together to figure out what's going on. Next slide. And one of the interesting things that I think is really changing here with regard to all of this is how we interact with these computer models. It used to be just a keyboard, right? Now we have natural language processing. I can talk to the algorithm. I can talk to the model. Yeah, I can, and the model can kind of interact with me in kind of different ways with regard to it. So what used to be called the HMI, or the human machine interface, with traditional process automation systems is now undergoing dramatic change. But this next generation workforce is not that new to talking to their smartphone. The Siri application essentially, changes the interface. And of course, what we really want to get to is that get my data button that essentially will bring all of the relevant data in a common format to the analysts so that they can build their kind of view to that. We're not at that get my data button by a long shot yet, but the way we are interacting with the digital twin is very definitely changing. Next slide. So we've got to the point where I say now the industry is data rich, much more data being acquired in the oil field than it was when I started. But we are still information poor. And that's kind of one of the things that I try to work on, this whole idea of telling a good story with data to the students, is the fact that the whole visualization part of it is a really an area of going forward. Um, we have the data. Maybe the problem is finding the data we have, but there's a problem in terms of reporting. More and more management wants to know what's happening now, not a month ago, not a week ago, with regard to these things. So our inflexible static reports are almost obsolete the minute we produce them, right? Getting a reservoir study and a reserve calculation once a year is not good enough. I mean, you could have a reservoir simulator now that at least maybe in a part of it, I can get a new a reserve calculation a couple times a day. So, I mean, clearly this had a lot to do with advanced computing processing, high performance computing, as it's often called. And essentially, we have a lot of compute power, we have a lot of data. Now it's the idea of how to make good use of it. Next slide. So the whole concept of analytics and this data science kind of thing is where a really interesting kind of challenge these days. And in my view, my experience, the best approach is one of a team, not of an individual that knows everything. It is one where you have domain knowledge, which largely is the petroleum engineer. You have one with the math and statistics knowledge, which is largely the data scientist. And then you've got the people who know where the data is hidden. Um, and from that sort of team concept, and probably the petroleum engineer is the project lead, we are changing the way we are doing analytics. We used to have just the challenge of what happened, and that was our what management would ask us is what happened. Now management is asking us tougher questions. They're asking us, why did it happen? The forensic side of this thing. If a piece of equipment failed, why did it fail? And then what's likely to happen next? And this is the huge, big change on petroleum engineers, that they now have to work with these predictive models. They now have to become future tellers. They now have to answer questions of, so what is this reservoir well concept that I have? What is it going to do a year from now, 2 years from now? Because management's going to go take that answer and go borrow money with it, right? So or make investments with it. But we're not, as I said, we're not done yet. We're moving to the place where management is going to want these engineers to keep good things happening most of the time, which challenges our probabilistic kind of view of the data models that we try to have. So we're the optimization challenge is still ahead of us. Next slide. So the question, are algorithms taking over the world? The answer is absolutely yes. But we need to be careful about how we do that. So clearly, as they become more and more important, as that algorithm now sits on a piece of smart equipment in the field running my pumps or whatever, we have to have maybe redefine how the human is interacting with this system. And that's the role of the next generation. They will be the ones interacting with this automation differently than their predecessors. Next slide. So I had a question a little bit earlier on about the risk of these AI tools becoming just black boxes, that they come up with an answer, but we don't know why they came up with that answer. And I think this is another area for those who are building the models to be able to figure out and interrogate them, and have the AI model explain why they got the answer they got. And because these AI tools, machine learning tools, artificial neural nets, surrogate vector machines, all of these different sort of techniques are massive uh, correlation engines. And with more and more data and with cognitive generative AI, you've got tools now that eat the whole internet up to build their history matching models. We need to be able to figure out, why they did what they did, because putting in a whole lot of bad data, as Mike talked about, is a way of polluting the model, getting the model to go to wrong results, because the statistical theory of correlation is not causation. At the end of the day, we want to know what caused it, not what correlates with it, right? So the whole idea now of explainable AI, that's where an awful lot of the regulations in the EU is happening, where a lot of other people are trying to figure out, how can I get that black box to tell me how it did something? Not what the results are. That's easy. That's what it's doing today. But why did it do that? Because we now know these generative AI techniques being fed with wrong data, essentially what's now called hallucinate, which means they produce a wrong result because the data they have that they were trained on maybe didn't incorporate the problem that we're trying to solve. Next slide. Academic professors are really freaked out by ChatGPT because they are afraid that students will go to ChatGPT and have the algorithm do their homework for them. Well, I think unfortunately this one, the professors are going to lose this fight, because so I went out and asked my students that intentionally go to ChatGPT and to figure out and have them do their homework, and then to write a paragraph at the end grading how the ChatGPT did. And of course, their initial reactions were, "Wow, this is pretty good, and I could do this, and it could do my homework for me." But it needs to raise the game about ethics within the students and the professor, in terms of knowing that this technology is available and knowing how ethically to use the technology in the right kind of way. I had my courses as not open book or closed book. It was open everything, but you better cite your sources if you are going to use something else. That is intellectual dishonesty and could get you thrown out of class. But citing information is collaboration, and that's what you're expected to do in industry. So the challenge of, are these algorithms going to be competitors to the next generation workforce, or are they going to be coworkers? Will robots take over from humans, or will we actually find a way to work collaboratively with them? I hope it's the latter. That's what I'm optimistic about in terms of the future. Next slide. The office of the next generation workforce will look a lot like this. I mean, I saw a room a lot like this on Quito when I got a chance to go out there and visit. And it's just an awful lot of data. We have too much data. The human being will be inundated with data and not catch the safety signals on a system going wrong. We will need that digital twin. We will need that interface that will help the human being digest all of this data and just alert them on what's important, on the decisions that they can make. And this new role of the human is both in building the data-driven model and the statistical guardrail on the physical guardrails, but also then in being able to be there to interpret and intervene on the instances where the computer hasn't been trained on. The 5% of the time that something happens that really changes, how the whole platform works. Next slide. Well, that's why I believe digital literacy is a critical part of petroleum engineering education. It is, and it's kind of tough because they still need all the physics classes that are currently in their curriculum. This is a added skill, not a replaced skill. And so, in whatever way we try to do that to increase the digital literacy, with realistic data sets, with realistic history matching of our data-driven models, are going to make either the industry to be able to use these digital systems or struggle, be overwhelmed by the data that we collect, because we are collecting more, and the next generation production systems will have an order of magnitude even more data than it has now. Thank you very much.
All right. Thanks, Prof. I'll wrap up the session with a few slides. Tim has actually touched light on a lot of things and spoken from his experience as a lecturer and also shared insights into what he's currently doing with his students, basically. So that being said, I'm going to just talk about some other areas that have been mentioned, some applications in terms of drilling and completions where AI can also be used, right? Like I mentioned previously, that people are using machine learning to estimate rate of penetration for, drilling tools, and also ensuring mud composition using machine learning to determine accurate mud composition based on formation pressure. You could also use in terms of seismic horizon mapping, seismic interpretation, and also probability maps, and a lot of areas where AI is being used, which not be overemphasized. But more to this is, HSE compliance and monitoring, energy trading. You have energy trading, services where people also use this AI system and managing inventory levels, improving logistics and transportation. For that being said, I would like to share this, right? And this is where sometimes there's a bit of conflict when people say, if you are actually just like Prof had highlighted, where you have to ensure that the students need to actually, you said, if they want to build the models themselves, they need to have that skill set. For the academia, for probably some of us that are industry lecturers, where should we focus our energy on? And how should we, spread ourselves thin along this value chain of artificial intelligence or machine learning, right? So what you have there is a 5-layer component that spreads across, enables you to successfully deploy an ML system. This layer component starts with the use case. Looking at what research problem you're solving is typically important. Remember that we're tying it to what industry problem exists, basically. You're looking at the use case of what you're trying to solve, right? Probably as a lecturer. And more importantly, also, the question arises that you're looking at to focus on is what data will be available, either for the student who is going to work on those projects or for your research fellow. Where are you going to get data and how are you going to source for data? Data is a concern, and I'll address it going forward in my next slide. Also, basically, and then of course, you also must have some level of expertise in the use case you're looking at, right? It also will help the students. You're also able to supervise what they are about to do, what they are supposed to actually do, and what you're asking them to do. So basically, the domain expertise to understand the problem also resides on you as a lecturer or as a supervisor or whatever level your acting capacity, right? It also does not elicit, it doesn't exempt you from collaborating with people in the industry who have that domain knowledge. Say, for instance, the research is around carbon footprints, right? You could reach out to industry experts, basically, and check and send messages to them, cold emails, and say, we would like to be part of this research project, sharing your industry expertise on the domain understanding of what we want to do with respect to energy prediction using artificial intelligence. So this is actually shaping how each stakeholders can actually address the issues around AI. And of course, for the students, they could focus on probably building the machine learning model using Python or using whatever scripting language. They could also collaborate with students from other departments who could actually also help for building the machine learning. The most important is to understand that what you're seeing here as a workflow at each of the layer plays an important role in where you want to successfully deploy an ML solution. Because the end goal is that you're looking at, you want to be sure that there's a clear case of what we're solving. It's not arbitrary problem that is not solution centric to industry challenges, right? So you want to be sure that yes, there's a clear use case. You also want to say the concerns around data. You want to also look around how to source for data, right? Sometimes you could find ways to collaborate with people. Research institutes have some data, right? Basically, and they could provide some of those data that are requested. And then, of course, the domain experts could also collaborate. Basically that, and of course, for the students, it also does not exempt each category flowing. Say the student is looking at the machine learning part of things, and he also wants to understand the domain. Yeah, but this just helps to provide a basic ground rule for how you intend to interact, and also ensure that whatever the student is doing, the lecturer is in sync. The industry has, and the industry also has an information, right, that there's a particular problem solution that is being worked on in this institute that they can also leverage. The same also goes for the industry. You know, some industry are having digital transformation team. Some industry are having AI team. Some of them call it digital technology department, you know, as the case may be, right? So still the same case. Leadership focus on what's the business case of the solutions that we're looking at, and how is it going to help us, right? Is there data that is being used that is probably, you know, proprietary to us, basically, and you have to look at some of the non-disclosure agreements if you're going to exchange that data with a research institute. And that's one way we could actually work some of the things out. And of course, domain expertise. With respect to, you know, writing probably the ML algorithm, those could be outsourced to the academia, you know, basically, where the academia comes into play. It could also be done by, if the industry feels they want to have a, you know, a machine learning team and build a machine learning team. If that's their interest, they could actually have that and collaborate with the academia, and then also have probably outsource some of those things to the academia at large. And so this is like a typical, you know, ground rules for successfully deploying an ML system, because over time, we realize that there's always a confusion as to some people say, because it's ML, do I need to learn how to write the code? You know, if you're a leadership, your management, your lecturer, just understand what's the use case these people are solving. What's the use case, right? What's the solution? What's the problem we're looking at? And what solutions are we looking at? Is there enough data to carry out this research? You know, how do we get data? What collaborative means? And then, do we have domain expertise? Even as a senior person, you may not necessarily have the domain expertise, but you could collaborate with people in the industry, you know, who have that domain expertise of telling you how it's being done. And just like Prof said, that despite leaving the industry for a long period of time, he had to call industry to come and take certain courses in drilling. That's the way to have the synergy of knowledge and the flow of knowledge that could actually be beneficial to the economy at large. These are recommendations for lecturers on the call. The first one is to create a collaborative digital environment where students are taught certain programming language. This needs to come up because the idea is the students actually have their fast on their fingers and they are fast in their thoughts, and they can actually dedicate their time to learn some of this, you know, programming language. And also, it also helps to, in terms of maybe you're looking at the solution and looking at how to understand what's working behind the scene, right? It helps you, you know, like Prof mentioned that sometimes we don't know what's happening behind the scene. But the issue is because if the algorithms are not written by someone you know, or probably written by you, you probably need to understand what is running behind the scene, basically. So you need to actually create a digital environment where students are taught some of these things. I know SP does this machine learning training for, that's SP for Nigeria, does machine learning training for penultimate students, 400 level for 6 months. SP actually sponsors that, where they are taught machine learning, Python, specifically Python programming hands-on, basically. So academia needs to begin to, you know, be intentional about things like that, basically, and actually enforce that students learn some of this language. And then also, what we are doing, which we are going to do next year, we're trying to work on it, is we're going to create a platform, a collaborative platform where industry people will come and drop their challenges. Because one of the things like we mentioned is, how do the academia even know the challenge that the industry is looking at? So we're creating a platform where industry people could drop some of their challenges, maybe a summary, right, and about information. The platform is going to be a web platform, a digital platform. So they log in, they drop their challenges, and the academia also log in and pick any of those challenges and solve them, right? And once there's a solution from the academia, and then there could be we could have an interaction between the industry people who actually drop that problem, showcasing what solutions the academia now begins to showcase what solutions they've been able to do for the industry. That's something we are looking at to do for in DCIT Africa next year. It's like going to be a web platform where the industry a web platform. We're looking at a web platform, DCIT Africa, we're going to create a web platform where industry people will come, upload whatever problems they want to solve or challenges they are looking at, and the academia can log in, pick in those challenges, and probably assign to students. That way we can foster collaboration. That way we can bridge the gap, digitally, basically. And also, there's also going to be another thing is to create more like AI hubs or charge students with capstone projects. Think about a semester where students, by the time they are leaving for the semester, they are taking home certain machine learning projects, to study and come back and see what they can pull out of this. I mean, just little capstone project. It could even be analyzing data sets. It could be using some of these regression and algorithm, and then do a kind of prediction. These capstone projects, if they are inculcated earlier in the academic life of the students, say from 200 level, right? And then they could do those projects, they come back, they talk about it. You will have created a kind of, you will have built their competence over time. And before they get to a point where they are now doing research that are solving industry problems, you could see that they are actually providing solutions because over a period of time, they've built that competence. More or less, also, some of our recommendation is how can we revise curriculum? The current curriculum has to integrate machine learning and AI, right? Some schools, in Africa still has very old programming languages being taught, like Fortran. I mean, some of those languages are outdated. If you are building for the future, one of the things we should understand as academia, right, is that you build for tomorrow. You don't build for today. So if Fortran was the language of choice the previous years, was supposed to have moved from it because you're supposed to build the academia for the future, such that after probably 4-year, 5-year program, as they're coming out, they're already ahead of the curve and they are solving problems that are relevant to the industry, even when they get to the industry, or they could create solutions and, spin off companies, startups, and then they could begin to even employ other people, making the economic better. So you look how to revise some of the curriculum, have this conversation, basically, and discuss with some of these people. And also, we also talk about the issue with respect to data sets. Well, there's a Evolve data set where we could leverage that. There's an Equinor field. I think Equinor probably has this data set called Evolve data set that is available in public domain. It's actually an asset that was abandoned and they made their data set public. You could actually go online and search for it and download that data set, and you could actually use it to, run some, some analysis, play around with the data set to, do some kind of predictions or find out some insight. It typically covers the whole oil and gas value chain. I think petrophysics, geologists, and reservoir. There's a lot of data set there, so something we could actually leverage. That's basically that. And for industry, there needs to be a clear objective with respect to collaboration. They also need to be like, just like there's a structured collaboration framework, right? Also, more like what we're doing now, seminars and workshop platforms, basically to support, the whole initiatives. And of course, like I mentioned earlier, that the SP machine learning project, industry-based supervisors actually supervising the students who are actually doing 400 level students who are taking courses in ML. So basically, that is something. And finally, also embracing diversity and collaboration. So basically, these are more or less it. I think that's all. I think Prof has something else to add. Prof, over to you.
Just to build on your point about revised curriculum, I am prepared to donate the curriculum, the syllabus and curriculum that I've developed for my courses to university heads of department. So that's just one reference point to take a look at in terms of what extra that the Colorado School of Mines PE department is trying to do.
All right, thank you very much. Yeah.
Yes.
So thank you, Prof. Thank you for donating that So that's all. Over to you, Chi. Thank you very much.
Thank you, our presenters. I think they deserve, a round of virtual applause, and truly it's been a wonderful session, a lot of ideas, on how we can continue to leverage data science and engineering analytics and make those connections with the industry and the academia. So really, I wish we could clap physically for them, but what we can do now is digital clapping. So please, as much as possible, I think they've been very fantastic. So let's move on quickly to the questions and answer section. We had a couple of questions come through in the chat, and thank you for the participation and engagement. I will start with the first one. A couple have been responded to on the chat, but I'll just maybe start with the very first one from Priye. It says, question, only experienced academics with a blend of industry insights, tailor proposals, and leverage contacts for precise and relevant research. What's the way forward for those without industry experience? So I'll let Jim take a stab and then maybe Mike.
Well, I think Mike's point about using the SPE as a platform for reaching out to industry. If you don't have contacts that that you've worked with or whatever, and many young professors are exactly in that position. Using SPE to branch out, they are made up of these industry partners, and so going through an intermediate like the technical section that Elias leads and Chi and Joy are part of, that can help maybe connect someone to a brand new network, an industry network, if you don't have any particular experience. So I think one of the easiest ways to do that is just approach the local African DSAT committee and say, I would like to do this XYZ. This is my point of my course. Could you help me point me to somebody that might be interested in working with me? I think that might be an easiest way, and it's what SPE is kind of designed to do.
Okay, thank you very much, Jim. I think the next question you responded to it on the chat, but I'll let maybe Mike take a stab as well. It says, from Israel, good evening. Thanks for the very informative webinar. Although I am a graduate of computer science, currently working as a software Q&A engineer, but I still have a keen interest in AI research and ethics. How can I transition?
Thanks for that excellent question. So transitioning into AI is as simple as it is, right? You're already into computer science. So what you can do is to see how you could join Ethics of AI platform. You also have lawyers who are transitioning into Ethics of AI as their career base, right? There is also Professor David Leslie, Professor Shannon Valor. Some of these guys are available. You can start by reading some of their materials that they publish with respect to ethics of AI. Basically, you also need to understand some of the modalities around ethics of AI, from transparency to responsibility to desirability. You need to understand that, and then you need to pick a niche if you want to stay on responsible AI. So when you see people being flagged, I know I was trying to address some things where somebody said on social media he was being prevented from making comments. And I said, that's responsible AI. So responsible AI focuses on flagging violent speech and hate speech or things like that, violent words, right? So it's easier. All you need to do is probably send a cold email to some of these professors, join some of their research group, right? And then they can onboard you into what they're doing. And then it's something very good. But irrespective of your career path, it's something petroleum engineers are actually switching to it also. Software developers, computer scientists, engineering general, because AI is generic, covers all this. So you can easily switch that way by reaching out to some of these people, and then they add it to their research groups. Yeah, thanks.
Thank you. Excellent. Next question. Again, Jim has responded to this, but I'll let two of you maybe chime in more. Said, thank you for putting this together. Please, can you recommend some online training platforms for AI? Thank you. That's from Charles. Maybe
Okay.
Mike,
Let
you
me
want
let,
to go?
let,
Or,
let, let, let me answer that. Let me answer that, right? So, if you want to learn AI, so like I said, AI is the overall goal, right? I'd rather say you learn the programming languages first. The Python. You need to understand what those languages do. PyCharm, TensorFlow, what they do, right? You pick small data sets, basically. You can go to Kaggle. So what I do when I in my company, Cypher Crescent, a young lady just joined us this year and interned in my department, had no knowledge of machine learning and AI whatsoever. So what I started with, I took her through, I took her through Python, said she learned Python, and then had some data sets from Kaggle. That's the Titanic data set. So when you learn those Python programming language, right, you could pick data sets from Kaggle and use Python to analyze them. There are platforms that you can learn Python from. You have plural sites, you have Udemy, you have Coursera, you have a lot of sites like that that can actually teach you those things. Once you begin to build from the ground that way, you begin to analyze data with Python, and then, like I mentioned, she now went to machine learning. She was able to do prediction, logistics regression, linear regression. That's where you build competence in what you're predicting. You begin to now grow those competence to the upper level of looking at machine learning, deep learning, and then the whole AI system. So start small, grow big, and that's what I would say. So use those platforms, Coursera to learn those programming skills, Udemy, plural sites, and the likes. Yeah, thanks.
thank you, Mike. Thank you so much for that response.
And if I can just add one thing to that, it might be a little bit scary to a petroleum engineer saying they need to learn more programming languages, but the languages we're talking about for machine learning are what's called low code programming, and they're not like C++ or JavaScript or the languages that the computer scientists use. They really don't involve an awful lot of code. A lot of it is just calling on existing subroutines for analysis, for data ingestion, for um, you know, uh, presentation, making graphs and stuff like that. So it really is it's not so much writing thousands of lines of code, which petroleum engineer may not want to learn, but it's just writing tens of lines of code, calling these subroutines and essentially putting a processing approach together. And the amount of code you write is minimal and is not that scary. I mean, my students have no trouble, learning the Python sort of an approach and still being engineers. They're not changing their lifestyle over to computer science. It is just it's a tool that's easier to adopt, and these low code languages like Python, like R, are ways that all engineers can become pretty decent programmers. See, and you're not going to be the one in the company that's going to write the 1,000 lines of code. But you're going to are going to be one that has to know how to build some of these models.
Yes, thank you very much, Jim. I think the next one also you had responded on the chat. It says, how does U.S. academia overcome data sourcing challenges for research? I know it's one question that a lot of the academia, especially in Nigeria and Africa, might have at the back of their minds. You want to elaborate more?
Well, Mike did mention the Vol field data set that Equinor/Statoil has put out into the public domain for data, and that is an amazing data set that goes all the way from seismic to reservoir production drilling around a particular field. So there's an awful lot of research been done by in academia by students, etc., just using that data set that's available. So that's a great place to start. The other, I mean, it is a problem, and companies don't often like to donate large data sets, and they often are concerned about protection and security, and they may not want to have certain things published in a paper or in a thesis or something like that. So it does take some time to build a kind of relationship with a company in order to do that, and the academia may have to make some um, compromises in terms of how it's going to use the data, anonymizing data sets so you don't know what well is what, or different things around that. Then and promising not to use certain data in a public presentation or something. So it's not easy, and this is a one where I recognize I've been on both sides of the conversation that a lot of operators don't really like to do big data donations. But if you're focused on your problem and you have a good relationship and you say that I'm producing a student that you might want to hire and they need this skill set and you're going to appreciate that. It takes some conversation and it takes some compromises, but it's possible. But this is one of the hard challenges that's true for everybody, not just an African university, but a North American university has similar problems.
Thank you, Jim. I think the next question from Finehas says, in terms of skills development, what are the key AI-related competencies that would empower African petroleum engineering students to contribute effectively to the industry technological advancement? I think a lot of this has been said already. I don't know if Mike or Jim, if you want to maybe add anything, otherwise we'll go to the next.
I think that, yeah, for petroleum engineer, I think Jim has also said it, right? Where I like the fact that he also mentioned the low-code solutions, right? These are more like, the world is even transitioning to people, using low-code solutions. So some of your low-code solutions is just like a drag and drop where you're creating workflows and then it's being automated, right? So with respect to skill sets, a lot has been mentioned, right? It's either I think it's more of, for me, I think it's more of a choice if you want to be hands-on, building the models and doing all that. Or if you really want to take your time to understand the data by running the data analysis, typically before you build models, you should have carried out what we call exploratory data analysis. You must know the features your data represents, right? So probably, some of those skills that were mentioned, Python, R, whatever the case, whatever those languages are, PyTorch, TensorFlow, and the likes, or you go for low code or no code solutions that are more like drag and drop. I know Google has one. I'll drop it on the chat area. And Microsoft also has one that is a low code solution that helps you understand AI. So basically, you want to either learn the skill or understand the workflow, right? So some of these are things you can actually pick up. But I think for more from the academia is revision of the curriculum. Imagine if you're being taught, if there's a curriculum that says this semester you're going to learn introduction to Python. I know schools like Covenant University in Nigeria are doing something similar, right? And then it helps you to build those competence, and then it also helps to position you for the future. Yeah, thanks.
Yeah, I think we'll probably have just time for one more question. I'll take that from Alex. Alex says, how do regulatory and safety consideration in the oil and gas industry impact the balance between model interpretability and performance? Also, are there examples of situations in the industry where high model performance is critical, but interpretability can be compromised? Any takers for that?
Let me take that. Let me Prof can add. So there's what we call in software development or machine learning development, there's what we call test environment and production environment, right? You do all your model building and deployment on the test environment. So let me just typically walk back. The reason students are given tests in school is to see areas they need to improve on before the final exam. So it's like you say the test is over 30, right? Basically, it's just to see areas to improve on, right? But I think most days that has been changed to people say I must score all in the test. So in software development and deployment, there's a test environment. When you are in the test environment and your model's performance or predictability, it is not in compliance with what the industry is expecting, you can't take it to production, right? So that is how we're able to monitor and regulate some of these concerns that you have regarding the model performance. There's actually that the development cycle workflow focuses more on test-driven development and ensure that until it passes all the tests. So the tests are the exact use case and replica of what you expect in the industry for that particular thing. If it passes all the test case, then you can take it to production. Even at the production, before you get to production, there's staging environment where the staging just mimics the exact industry itself. the exact company problem. You stay at the staging, you are monitoring it to perfection. So these are things before you actually now automatically deploy it. Then also in terms of DevOps, there are rollbacks where you notice that probably what you're deploying is not the performance is not what you're expecting. So there's a quick rollback to the previous state so that you don't have some of these issues. So basically, there are regulatory policies from both industry and both development perspective that helps to guide some of these things. Yeah, I mean, the Prof can add to it too.
Well, just to add to that, I mean, the idea of a regulatory environment, they usually are not interested in financial decisions. If the operator makes a bad decision, lose a bunch of money, the regulatory agencies don't care that much. But safety is an issue. And safety usually in the oil field is about pressure management. And so ideas about, I mean, all the way from drilling to, fracking, and particularly we're talking about unconventional reservoirs. Many reservoirs are fracked these days. Handling that there's certainly a safety concern. So therefore, if you're using a lot of analytical tools to design a fracking program, they'll be interested. But now increasingly, and the COP28 just finished, but we're using a lot of predictive models to predict our methane emissions or methane intensity. And so therefore, the regulatory agencies are going to be very curious and very interested in how we do that. It's maybe part of our permit, to our license to operate. And so I think that's another area of where data-driven physics and statistics modeling that the oil industry will use, but the results and the reporting back to the regulatory agencies is going to be one that they're going to be very interested in how we did something.
So thank you very much, Jim and Mike. Another round of virtual applause for Jim and Mike. It's been a wonderful session. I think for right now, as per the agenda, we'll move to how SPE can support. And I think we have our regional director in the room to take that. Ogogo Effium, if you're
Oh, hi everyone.
on the floor. Yes.
Thank you. My apologies. I was supposed to have come earlier on this, but I mean I was in transit and I just was able to join a Wi-Fi area. So it's good to see so many people joining the session. Okay, so I want to first of all thank everyone who has joined and everyone who supported the this event to take place. It's hasn't been easy to put together the agenda and get our eminent speaker to join us. So thank you everyone who had a hand in this. In terms of SPE's role in sharing the knowledge of data science in Africa, there are some initiatives being put together by the groups. This webinar is one of them. There will be a series of them next year. We're going to organize some sessions, some courses for students in Africa as well. There are going to be things like hackathons. Now, just to let us know that hackathons have been taking place in other regions successfully, and I don't see why we in Africa can't also have that. So I'm really pleased to have this team running those sort of events on a regional level now. So not just talking about one section or the other, but across the whole of Africa. There will also be some recognized institutions and some lecturers who are interested in machine learning or who have it. They would be able to be part of these initiatives going forward. And any of us who was a volunteer across Africa who is interested in machine learning can also be part of this technical section. As everybody knows, my desire for SPE in Africa has always been that we should have a lot more collaboration. I think when I discuss and I speak to different sections across Africa, be it in different countries, there's a lot of brilliance amongst ourselves. So you can imagine just how brilliant we can be if we just could pull together and if we collaborate more. So that's my aspiration for this technical section, is to create a place where all of us across Africa can collaborate. So thank you. Over to you, Chi. And thanks for giving me this small time to interact with our members. Thank you. Go ahead, please.
Thank you so much, Ogogo. You've been a big supporter of DCIT, and thank you for all the efforts. At least from a regional director standpoint, and how you continue to support our initiatives going forward as a new technical session that we're just standing up. Thank you very much. So moving on to the next on the agenda, the message from our sponsors. So this webinar wouldn't have been possible if we, we didn't collaborate with the Port Harcourt, Lagos, and Ghana sections. So it's truly an African webinar. So if we have any of the section chairperson here, if you just want to say a word or two, you're welcome. Starting with the Port Harcourt, if you're here, Port Harcourt chairperson. Or Lagos, if Lagos is here, or Ghana.
Okay, all right, so I'll say a few words. Okay, Lagos.
Okay, all right. Yeah, so Lagos is glad to be, collaborating with SPE DCIT Africa. I think this is a brilliant webinar, and we're really glad to be part of this. I would say that in terms of industrialization, Africa is really behind. We're trying to catch up, and then COP28 has come to say we're transitioning away from fossil fuels. Now we need these fossil fuels to be able to industrialize. The fourth industrial revolution has come, and AI, machine learning, and co are things that can, Africa can really, get in the forefront and start, getting ourselves even more involved. So I would say that as much as possible, all that's been shared today, more or less, more collaboration between the academia, the industry, is really essential for Africa, and we need to win, and not be way behind as we are in terms of, industrialization. So I would say this is a welcome development. SPE Lagos will continue to support and sponsor and give support to this kind of events. Thank you very much.
Hello, Chi.
Right. So from the SPE Ghana section, I would like to thank our fellow collaborators for helping us put together such an important information on AI. The AI revolution, as we all know, has taken off, and then it will lead us into the future. On behalf of the SPE Ghana section, the board, and then the section officers, I wish to convey our gratitude for everyone here that joined us for today. We in the SPE Ghana section, we organized a training session specifically on AI this year, just to educate our members. So this particular lecture didn't come at the right time, and we are very much grateful. Next year, we look forward to collaborating with more sections and then organizing more events of such nature to benefit our members. Once again, I'd like to thank you all for joining us, and I will encourage us. So we are in the last month of the year. Kindly let's renew our membership to be able to enjoy the benefits that SPE brings. Thank you very much, and you have a fruitful day.
Yes, so thank you, James and B, for that support. You guys, whenever we call on you, you're always there, and Port Harcourt as well. So we'll continue to collaborate. This is a journey we just began. I think our last item on the agenda is closing remarks. So I'll let Joy to take that, or Stella, and then just show us a few slides on how to join the seats. Thank you. Joy, over to you.
Okay, thank you, Chi. Okay, please, Michael, take us to how to join the seats. So talking about renewing our membership, I want to believe most of us on this call are SPE members. and some of us on the call are also DCIT members. So if you are not a member of DCIT, please can we get, if you're a DCIT member, just in the chat box, tell us yes, or if you're not a DCIT member, tell us no. Yes, so on that note, please remember to renew your membership. If you go to spe.org, you see how to renew your membership. If you're a student or unemployed, you can get a fee waiver for this year. So to join the states as an SP member, you go to spe.org, you log in. You have to be an SP member to be able to join the states. So you log in at the top right corner of your screen. You see a button to sign in. You click that. Next slide, please. Next slide. Okay, so once you've clicked that slide, you'll be prompted to, once you've clicked that button, you'll be prompted to input your email and your password and sign into your SP account. Michael, please, can you? Okay, so when you sign in, on the top right corner, there's a logo there where you see the account, the profile. It's like a human icon. So you click that and it will open your profile, and these options will come up. So you click at the bottom, you see professional online communities. That's the second to the last option. Please, next slide. You click on professional online communities. Yes. So it will show you a list of all the online communities. Okay, you click edit first. When you click it, you click edit. And then it will show you a list of all the professional online communities in SPE. So you can join as many as possible as they suit your interests. So amongst that is data science and engineering analytics. So you make sure you check that box and then you save that page. Next slide. You click save and that's it. You are a member of DCIT. So to be a part of the conversation online, you can go to connect.sp.org and navigate to DCIT to see the posts on the forum and to interact with other DCIT members internationally. We also have a group chat for members in Africa. So if you would like to be added to that group chat, you can drop your phone number in the chat box and I'll add you after this call. Thank you. So I want to thank everyone that has been here today. Thank you for this successful webinar. To all our attendees, thank you. To the speakers, thank you for the wonderful information you give us. In fact, there's been a lot of very useful information to both beginners and people that are experienced in this field. So I want to say a very big thank you. We also want to thank our sections, Lagos section, Port Harcourt section, Ghana section for collaborating with us to organize this. Thank you for all the support. Thank you for the publicity. Thank you to Port Harcourt section for letting us use your Zoom. We appreciate everyone here. And we want to thank the DCIT committee for the hard work they put into organizing this webinar. And thank you, everyone. Let's do well to always be a part of our events going forward. Yes, so this is we've come to the end of our webinar, and I'm sure we've learned a lot. Feel free to join us, to share with your networks, people that you feel will benefit from this. You can always invite them to join the seats. So this is the end. Thank you.
Yeah, thank you, everyone. Like you heard, from Joy. Again, it's been a wonderful session, and it wouldn't have been possible without your participation. So stay tuned with DCIT and look forward to more of this next year. Thank you. Have a great day, rest of your day. Thank you.
Great. Thanks, everyone. Good one. Thank you.